Hello my dear PU1 students, today I am here with a very special class for all of the PU1 students, that is the first PUC model question paper as published by Karnataka Exam Authority. Right, also you are aware that this year there will be no separate board exam for class 11th. Class 11th final examination will be conducted by your respective colleges. The question paper will be set by your colleges, and there is a high chance that many of the questions in your final exam will come from this prescribed model question paper. I know many colleges, they are lazy and they just pick up the questions from the model question papers, thinking that okay, students they have practiced model question paper multiple times, so mostly they can answer this model question paper easily, so and they will pass, so we don't have to worry too much about it. So that is the logic behind us doing the model question paper first. So in the model question paper I am going to give you all the tips, tricks that is possible for you, and I hope that all those who have completed their first PU exam, definitely they can come and check, and those who have not completed, obviously for them please let me know in the comment below that when is your physics exam for your first PUC, right? So without any delay, let's start with our lecture. First is obviously the MCQ session. So now let's look into the first question. The SI unit of plane angle is, obviously the first part of 15 questions are MCQs, and many students struggle in the MCQs, so you have to be careful. SI unit of plane angle is basically radian, okay. Steradian is the SI unit for solid angles. Degree per degree are not SI units, only radian is the SI unit for plane angle, and steradian is the SI unit for solid angle. Now next question. A rectilinear motion is a motion along a circular path in a plane, along a parabolic path, along a straight line. Very straightforward, easy MCQ. That rectilinear motion means motion in a straight line, right? Now a vector is multiplied with a negative integer. The direction of the resultant vector is same as that of the initial vector, opposite to that of the initial vector, perpendicular to the initial vector, along arbitrary direction. So if you multiply a vector with a negative sign, it represents the vector in the opposite direction. So initially, if v vector is in some direction, if you multiply with a negative integer, any negative integer, it will always represent a vector in the opposite direction. Magnitude will change, but direction will just be opposite. So correct answer is option B. Question number 4. A large force acting for a short time to produce a finite change in momentum is called an impulsive force, okay. So this is called an impulsive force. That is the definition of impulsive force. Very large force acting for a small duration, it is called impulsive force, okay. Two vectors A and B are acting at an angle of theta. The scalar product between them is written as. So how to write scalar product? What is the other name for scalar product? The other name for scalar product is dot product. So definitely we have to find something with dot, and whenever there is a dot, there is a cos, okay. Cos and dot are friend, so option C is the correct answer. You have to remember that if it is a cross product or vector product, then cross is friend with sine and dot is friend with cos, right? Now let's move on. Easy question. The analog of mass in rotational motion. Analog of mass means whatever quantity that is that behaves same as mass in rotational motion. So the answer is moment of inertia. Moment of inertia I is actually analog for rotational motion. For force it is torque, okay. For speed it is angular speed, and for mass it is moment of inertia, right. Next is acceleration due to gravity G decreases with height, increases with height, increases with depth, is independent of height. So we know that as we move up the ground, or if you go down the ground, that is in the depth of the earth, the gravitational acceleration decreases always, okay. The rate of decrease is different as you are going down or you are moving up. For different cases we have done the derivations as well, but here we can simply say sorry, not increase, definitely not increase, it is decreases with height right. Next question. Poisson's ratio is the ratio of, so you have to remember that Poisson ratio is lateral by longitudinal. You have to remember this, lateral by longitudinal, and both of the cases it is a strain. That is why Poisson ratio is the ratio, it is a unitless dimensionless quantity. Okay, so lateral strain by longitudinal strain, you have to find the correct option and answer it. Okay, that is why I used to remember, that is how lateral by longitudinal. Okay, lateral by longitudinal is Poisson's ratio. Okay, don't get confused, lateral comes first, longitudinal comes next. Next is the resistance of the relative motion between the layers of a liquid. So, resistance of relative motion between the layers of a liquid is called viscosity. Okay, if it is a normal plane, then that is called friction. For liquid, the same thing is called viscosity. Okay. Next is the column 1 is the list of modes of heat transfer and column 2 is the list of transport media. Identify the correct match. Very easy question. Conduction happens only in solid. So, obviously 1 is matching with C. Convection happens only in liquids or fluids, basically you can say in general. So, it is fluids, and radiation does not require any medium, it propagates like light. So, option B. So, 1 is C, 2 is A. So, let us see which there is only one correct answer, C. 1 is C. So, if you just identify one correct match, then mostly you do not have to do anything else. So, 1 is C, 2 is A and 3 is B. So, correct answer is option C. Now, next question, first law of thermodynamics is equivalent to law of conservation of charge, law of conservation of linear momentum, law of conservation of energy, law of conservation of angular momentum. So, we know first law is basically conservation of energy principle, right. Most of the laws that we will see in future either related to one of the conservation. Okay. So, in this case it is conservation of energy, and most laws will give you the conservation of energy. At constant temperature, pressure of a given mass of a gas varies inversely with its volume. Okay. So, pressure varies inversely with volume, that is, it is what is the name of the law? Boyle's law, Charles' law, Kelvin's law, Gay-Lussac's law. It is Boyle's law, right. Now, the circular motion of a particle with constant speed is periodic and oscillatory, periodic but not oscillatory, oscillatory but not periodic, neither periodic nor oscillatory. So, object is rotating in a circular path with a constant speed. Okay, that means the rotational speed is constant. Rotational speed is constant means after certain amount of time it is coming back to its initial position every time. Okay, suppose it takes 1 second, after every 1 second it is coming back to the same position, right. So, that means it is a periodic motion. Periodic motion is whatever repeats with time is called periodic motion. So, this is a periodic motion. Now, oscillatory motion means is there a point on the path of the motion of the particle where if you stop it, it will be completely stopped, and if you slightly displace it from there, it will start moving again. Is it there? So, this is a motion assuming it is being rotated like some arm or something like that. Okay. Then even if you stop it using your hand, even if you release it, it will start moving as long as the system is working, right. So, there is no point where you can actually stop this object, or even if you are able to stop it, even if, it will not move after you release it. Okay. If it is rotating in a particle with circular motion, in case of circular motion it is periodic but not necessarily oscillatory. Okay. Clear? Now, next question, the minimum distance between 2 points on a wave having same phase is called. So, minimum distance between particles of point having the same phase is called the wavelength. Okay. It is called the wavelength, we know this is called wavelength lambda. Okay. It can be any 2 points. Generally we say that distance between 2 consecutive crests or 2 consecutive troughs is called wavelength. Okay. But it can be any 2 points having the same phase. So, that is the wavelength. Now, question number 15, sorry, the FIB is wrongly written here, FIB will come after this. Following are the 2 statements about the vibration of air column. Statement 1, when an air column is with one end closed, vibrates, node is formed at the closed end. So when an air column is vibrating with one end closed, we know that the vibration can only happen when there is a node present at the closed end, right. So because there is no possibility of any vibration of air molecules, so definitely it will be a node. So first statement is correct. At the closed end, pressure changes are the largest while the displacement is 0. So definitely all the particles are generally concentrated here, so pressure changes is largest, and the particles are not moving, so definitely the displacement is 0. That is why it is called a node. At any node, the particle pressure difference is maximum and the speed is 0, right. So that is displacement is 0, sorry, the displacement is 0, that is why it is called a node. So basically this is the explanation for the statement 1. So both statement 1 and 2 are true, and 2 is the correct explanation of statement 1. This kind of new type of questions are coming, keep coming on your PU exam. So be careful, you have to understand that both statements are correct or not. If one statement is incorrect, then which statement is correct, based on that you have to choose the options. Okay, and those who are preparing for NEET exams, these are very common questions in NEET exam as well. Now let's move into the FIB. So FIB label was somehow misplaced. Okay, so here it will be FIB. Okay, let's see. So first question is, there are options given: thermometer, elastic, velocity, mean, pressure, calorimeter. Let's see. In pure translational motion, at any instant of time, all particles of the body have the same. So pure translation motion, and it is moving in a straight line, right. So all particles of the body at any instant of time, they will have the same velocity. From the option, definitely it is clear. If you see, if you try to match, anything else is not matching. Okay, you cannot even match anything else with this. Linear translation motion means it has to be either velocity, speed, acceleration, something like that. But only one option is given, that is velocity. So we can simply say correct answer is velocity. Now a device used to measure heat. So which device is used to measure heat? Heat is measured using calorimeter. Don't confuse with thermometer. Thermometer is used to measure temperature, whereas calorimeter is used to measure the heat. So there is an option here, either thermometer or calorimeter, but in this case calorimeter is the correct answer, not the thermometer. So don't get confused. In an isobaric process, the quantity that remains constant. So iso refers to the constant. Okay, bar refers to pressure. Okay, you have to remember that bar refers to pressure. One of the unit of pressure is also bar. Okay, not SI unit, but one of the unit is bar. So baric means, isobaric means constant pressure. So if you see in the option also, no other option can be given in this case. Isobaric process. Can you say elastic? Constant is elastic. So this is related to thermodynamics. Thermodynamics question means nothing is related to thermodynamics other than pressure. So definitely pressure is the answer. According to kinetic theory, all collisions between molecules of an ideal gas. This is easy question. Postulates of kinetic theory. In kinetic theory, you know that all molecules collide elastically. So they are basically elastic in nature. Now in simple harmonic motion, the restoring force is always directed towards the mean position. Okay, so if you see again, no other correct option is possible. We have already used elastic, we have already used pressure, only mean and thermometer is left. So it cannot point towards thermometer position, it can only point towards mean position. So this is a smart way to answer questions in fill in the blanks. That is, you have to use your logical thinking. If I put this word in this gap, is it making any sense or not? So even if you don't know the answer, you have to be careful. Just check if this word, if I put it here, if it is making any proper sense or not. If it is making proper sense, yes, you can use, but if you are not aware, if you are not sure about particular fill in the blanks, leave it, check all the others, then whatever is left, two options will be still left, and then compare between these two and see whatever is making some sense, right? For example, in this case, if you don't know the device used to measure heat, maybe you will answer thermometer. You can answer that, that makes a sense, but thermometer is basically a trap. It is not the correct thing that measures heat, that is the calorimeter. So even if you make mistakes, you can still score 4. So that is why I say first you answer whatever you know. okay, because if you make mistakes in some of the question, then you might be confused with other options as well. So, if you do not know, leave it, check other options and come back to that part after you completed the fill in the blanks. Very scoring part, do not miss out on this. Next is write any two applications of dimensional analysis from the first chapter, units and dimension. Let us see. So, how can we use the dimension analysis? There are 2 points. First of all, checking the dimensional consistency of equations. Okay. For an equation to be dimensionally consistent, the dimensions on both sides of the equation must match. So, if I say force equals to ma, then whatever is on the left hand side, the same dimension should be on the right hand side as well. So, this is what is called dimensional consistency. Next, move on to the deducing the relation among the physical quantities. In some cases, we do not know the exact relationship, how it is related. So, in that case, we know that for example, time period is related to few quantities L, maybe G, maybe X, whatever it is. Okay, so we know they are dependent on these quantities. So, we will say it is proper to the power A, to the power B, to the power C, and then we solve it, right. We have solved that. So, deducing the relationship between amongst the physical quantities, how and which of the fundamental quantities are involved in a physical quantity, very important to know, right. Next is what is meant by free fall, what is the direction of acceleration in free fall. Let us see. So, free fall is a motion of an object under the influence of gravity alone with no other forces acting on it, like air resistance, okay, no other forces acts on it. The direction of acceleration is downwards, this is also correct, right. So, basically simple question, gravitation, free fall means object is falling under the gravity, only motion under the gravity, no other force is acting on it, right. So, that is called free fall, and when the object is falling freely, only gravitational acceleration is acting, and gravitational acceleration is acting which direction? Downward direction, right. Now, write the, or you can say mention that towards the center of the earth, that will be technically correct also, but in my opinion downward is sufficient. Write the expression for the centripetal acceleration and explain the terms. So, what is the centripetal acceleration? You have to remember they are asked you centripetal acceleration, not centripetal force. So, in that case what you can do, you can remember the formula for centripetal force as well. Okay. If you remember this formula, okay, you can find the centripetal acceleration as well. What is acceleration? Acceleration is basically F by m. In case you forgot, in case if you remember that acceleration is v square by r, very well, you can do that. In case you forgot, you can remember this is more most commonly used, more times it is used than centripetal acceleration. That is why it is more common to, more easy to remember, right. So, acceleration is basically v square by r. What is the term? A is acceleration, okay, v is speed, okay, and r is the radius of the rotation, right. So, radius of the circle, radius of the circular path, radius of the circular path I think will be better. Okay, it can, it does not necessarily to be a complete circle, even if it is the path is not complete, there still can be centripetal acceleration. So, it will be circular path. Right. Now, next move on to the next part. Write any two methods of reducing friction. There are mainly 2-3 methods that is given in your books also. Lubrication, applying substances like oil or grease between the surfaces to helps to reduce the friction by creating smooth layer that allows them to slide easily. That is one. And second is using ball bearings. Okay, ball bearings reduce the friction in machines by replacing the sliding motion with rolling motion, which has much less resistance. So, rotational friction is lesser than that of the linear friction. That is why we use ball bearings to reduce. These are the two common answers. Okay, any guidebook if you follow, they will give you the same answer. Next is question number 25. State the two conditions under which a force does not work. So, there are two conditions. One is obviously when displacement is 0. Second one is when the force and displacement are perpendicular. So, work done is basically given by F dot S, right, or Fs cos theta, right. So, if either F cannot be 0, obviously we are assuming that if there is no force, obviously work will be 0. So, if you are not trying, you will fail in the exam, right. So, how can you fail in the exam? What are the different ways to fail in the exam? The same question is like this. So, if you are not attempting the exam itself, definitely you will fail. You will be marked as absent and you will not pass in that exam. Now, there are two ways. Either you write the wrong answer, either you don't write the answer for that question, okay. So, you don't write, suppose there is a question, you don't write the answer for that question, that is displacement is equals to 0, or you write a wrong answer. Wrong answer means theta is equals to 90 degrees. So, if you are writing any wrong answer, that means theta is equals to 90 degrees, cos 90 is 0. So, in that case also your marks can be 0. So, let us see the answer. Displacement is 0, that is the object does not move under the influence of force. So, the example is if you are pushing a wall, okay, if you push a wall very hard, the wall does not move. So, you cannot say that I have done some work, even though you are sweating, you have applied a lot of force, but still the wall does not move. So, that is that does not count as work. Now, next is the force and the displacement are perpendicular to each other. So, if the force and displacement are perpendicular to each other, then cos theta is 0, then work done is 0. There are a lot of examples. One example is that a railway coolie is carrying a load in his head, okay, he is moving in the forward direction, whereas the load against which he is doing the work, that is the gravitational force, right. So, gravitational force is acting downwards, but he is moving forward. So, they are perpendicular. So, this is a no work force. This is called no work force. Now, question number 26. A structural steel rod has an area of cross section 3.14 into 10 to the power of minus 4 meter square and a length of 0.1 meter. A 100 kilonewton force stretches it along its length. Find the stress on the rod. So, here we have one extra quantity which is not required, that is the length of the rod. Okay, stress is basically defined by force by area. Okay, so what is the force here? Force is 100 kilonewton. Kilonewton means 10 to the power of 3 newtons. This is the force. Okay, what is the area? Area is given by 3.14, okay, into 10 to the power of minus 4. So, this is the stress, and the unit you have to be careful, that is Newton per meter square. Stress is unit is Newton per meter square. So, if you do not write the unit, the problem is very small and easy. Okay. So, you will get the answer, I think 33, around 33 or 31, 31 I think. Okay. If it is only 3, it will be 33.33, but there is 0.14. You can check and let me know if my answer was correct. I think 32, 31.8 will be the answer. Okay. So, it will be 10 to the power of 7 Newton per meter square. If you know the answer, let me know in the comment below. Use your calculator to calculate. Now, you do not need to calculate this 10 to the powers, it is easy. 10 to the power of 3, and there was a division 10 to the power of minus 4. So, this goes up and this multiplies. So, 10 to the power of 3 plus 4 in the power. So, it becomes 10 to the power of 7, right. I hope you understand this. Now, next question. State the law of equipartition of energy. Give the number of degrees of freedom for a monoatomic gas molecule. Okay, so, what is the equipartition of energy? Let us see the statement. The law of equipartition of energy states that in thermal equilibrium, the total energy of a system is equally distributed among all its degrees of freedom. So, first of all, in thermal equilibrium, you have to mention this. Okay, in my opinion, this is slightly tricky question. If you miss any important terms, the teacher might deduct some marks for it. Okay, so the law of, even though it is easy. So, energy distributed, I know many of you will write energy distributed per degrees of freedom is half kBT. That is, you have to mention thermal equilibrium. Okay, the total energy of the system is equally distributed among all its degrees of freedom. Each degrees of freedom contributes half kBT, where kB is the Boltzmann constant and T is the temperature in Kelvin. Very important, T is temperature in Kelvin, to the average energy per molecule. So, basically half kBT is contributed by the all degrees of freedom to calculate the average energy per molecule. So, for one molecule, each degrees of freedom is contributing half kBT. Okay, you have to mention what is kb, what is T, right. Degrees of freedom for a monoatomic gas is 3. We know for a diatomic gas with a bond, it is given by 5, right. Triatomic gas depends on how it is oriented, but for monoatomic gas it is always 3, for diatomic gas it is 5. Now, let us look into the 28. Write any two differences between longitudinal and transverse waves. Okay, let us see. So, there are two differences you have to write, longitudinal and transverse. So, first of all is particle motion, how the particle is moving. Particles vibrate parallel to the wave's direction of propagation. Okay, so longitudinal wave means particles are vibrating in the direction parallel to the direction of motion. In case of transverse wave, particles vibrate in the perpendicular direction to the direction of motion. Okay, the direction of motion, particle vibrate in the perpendicular direction. Okay, example is sound waves in air and water waves, light waves. Okay, water waves like when you drop something onto the water. Okay, the water waves that is created, that is a example of transverse waves. So, easy answer. So, first you write what is the meaning of them, and then in the second point you give one examples, as easy as that. Now, next derive, now it is a 3 marks question. Derive the kinematic equation V equals to V naught plus AT using VT graph where the symbols are usual meaning. Generally a graph based questions used to come in the 5 mark category. Now, this year they have given this into the 3 mark category, thinking that okay, we will reduce the difficulty level, but it is actually very easy to prove. This is the easiest question in entire question paper. So, only thing that you have to draw is this diagram, that is it. If you draw this diagram, nothing is there in the question, right. So, what is the acceleration? Acceleration is basically from the definition is basically slope of this graph. Okay, slope, this is the particle, this particle is moving along this. So, this is the slope of this graph. If this is theta, okay, slope is basically given by tan theta. Or there is another definition of slope. Even if you do not know what is slope, you know the definition of acceleration. So, you can say that acceleration is given by slope, okay, slope or gradient. Okay, if you have learned that in mathematics, it will be easy. Slope is basically delta y by delta x. Okay, delta y by delta x. So, what is delta y here? Delta y is this difference. So, this is the angle that we are trying to calculate. Delta y is this, delta x is this. As simple as this. What is delta y? Delta y is basically V minus V naught. So, delta y is V minus V naught, and what is delta x? Delta x is this time, total time taken T. Okay. So, because they have mentioned it, use the graph, that is why you have to mention the term slope here. Okay. If you do not mention the term slope, the teacher might deduct marks. So, only because they have mentioned this using graphically. If you see in your textbook also, they have not used any graphical method for this derivation. There are other derivations, s is equal to ut plus half at square, v square is equal to u square plus 2as. They are being done in graphical manner, but here this is the easiest. What you can do? This is the definition of acceleration, or you can say okay, maximum we can say that slow acceleration is basically slope of the VT graph. So, from there we can calculate that AT is basically equals to V minus V naught, or V equals to V naught plus AT. As simple as that. If you write it, you get full marks. Okay, and please let me know if you have completed your exam and if you have get this question or not. Now, next question, define equal vectors, unit vector and null vector. Okay, so let us see what is equal vector. Equal vector are two vectors are said to be equal if they have the same magnitude and same direction regardless of their initial positions. Okay, equal vector means they can be at different positions, their initial positions can be different, but they has to have the same magnitude as well as same direction, then only they are being called equal vector. They can locate at different positions, that is fine, but equal vector means same magnitude and same direction. Okay. So, for example, point A is 3, 4 and point B is also 3, 4, then A is equals to B. Okay, A vector is equals to B. Okay, this is a coordinate vector. we sometimes write vectors in terms of coordinates, right? So what is the meaning of a vector? 3 I cap plus 4 j cap. Here also 3 I cap plus 4 j cap, both have the same magnitude, same direction, so they are called equal vector. This is the question. Next is unit vector. A unit vector is a vector that has a magnitude of 1 and point in a specific direction. It is used to indicate the direction only. A unit vector A cap in the direction of the vector A is given by A cap is basically A by modulus of A. Okay, this is unit vector. So unit vector has only the direction and its unit is its magnitude is basically 1. So 1 magnitude and the direction is called unit vector. I cap, j cap, k cap, they are all unit vectors. Null vector, 0 vector. A null vector or 0 vector is a vector with 0 magnitude and no specific direction in represented as phi. Okay, this is the null sign. Okay, it may have a it may have a sense, but it does not have a particular specific direction. Okay, so for example, if you have started, you are sitting inside a car, the car has just started. Okay, the machine started rotating. Now at this point of time, the car is neither moving nor it is, you can say this is static. Okay, so car can go right, car can go left, car can go straight. Okay, car can go backside also using reverse gear, right? So that is an example of null vector. When the car machine is running but car is not moving, it can go any particular direction, any direction. So no particular sense of direction, but still it has what I said, the magnitude is 0. For example, if you do the cross product of two parallel vectors, cross product means definitely it is a vector quantity, but if you do the two parallel vectors cross product means it is a 0, because sin 0 is 0. So A cross B is basically AB sin theta, so sin theta 0 means the vector itself is 0, right? But it is a vector quantity, so you have to denote it with something that is given by this particular symbol, 0 with its belly cut, that is the symbol of null vector. Okay. Now using Newton's second law of motion, derive F equals to ma. Okay. So what is Newton's second law of motion? I am going to give you a easiest solution, but slightly mathematically maybe you might find this difficult because you may not be familiar with differentiation. So if you are not familiar with the differentiation, then definitely you can attempt whatever is given in your textbook, and those who have done the differentiation already, they can use the method that I am going to show you. So according to Newton's second law of motion, okay, we know that force acting on a body is proportional to rate of change of momentum. Now rate of change of momentum is basically given by dp by dt. So dp by dt, that is the differentiation, is differentiation of p with respect to time is the rate of change. Differentiation represents rate of change. Okay, I have done a basic physics video in the past, you can go and check that out. Otherwise, differentiation basically means the rate of change, basically delta p by delta t, that is also a way of writing. Now what is p? P is momentum. So force acting on an object is directly proportional to rate of change of momentum. So what is momentum? Momentum is mass into velocity, right? Momentum is basically mass into velocity. So what we have to do? We can remove the proportionality sign. If we remove the proportionality sign, then what we have to do? We have to use a constant of proportionality k, okay, and then we can say that d mv by t. Now if you remember the differentiation says that if there is a constant inside the differentiation, that can come out without having any trouble. So what is that? That means m will come out, because m of an object is generally constant, okay. Most of the cases it is constant, so m will come out, so m dv by dt, right. Here you have to mention what is k. K is constant of proportionality. Okay, we have to mention that. Now what is dv by dt? dv by dt is, now we said that dp by dt represents rate of change of momentum. So dv by dt represents rate of change of velocity. Now what is the rate of change of velocity according to definition? So rate of change of velocity is basically acceleration, right. So from second law, this is the statement, and here you have to mention P equals to mv equals to momentum, MOM. Okay. Now this is up. After this, I have seen many students, they somehow, whatever method they will use, they will, after some day process, you will arrive here. Okay, now I have seen that put, it is written in one of the guidebook as well, put K is equal to 1. So F is equal to MA. What if I put K is equal to 100? Will that be MA? I can put any number. If you mention put, why should I put 1? Right? So that has to be clearly mentioned in this derivation. If you don't mention it, teacher will deduct 1 mark. You cannot write put K is equal to 1. Why should I put K is equal to 1 and not 100 or not 1000 or not any arbitrary value? That is very, very important in this derivation. Very careful. You have to mention that the unit force is defined by m equals to 1 unit and a equals to 1 unit. Then F will be equals to 1 unit. It can be any unit, SI, CGS does not matter. So this is how it is defined. Therefore 1 equals to K into 1 into 1. So that is why K is equals to 1. So the actual value of K is 1. You don't need to put anything for that. Okay, this is one of the known value. If there is an equation you are solving, and if you know one of the known values, then using that values you can find the constant in the equation, right? Similarly here also, what we have done, we know that unit force is defined by when acceleration is 1, mass is 1, then that force is called unit force, that is F is equal to 1, right? So in using that we can say now therefore F equals to MA, that is the derivation. You score full 3 marks. Okay, so this line is very, 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 very important. If you don't write it, it depends on your college. Some teachers might like it, some teachers don't like it. If I am evaluating your paper, definitely I will deduct your mark if you write put K equals to 1. Now question number 32. A woman draws a bucket full of water weighing 10 kg from a well, which water level is 8 meter below in 9.8 second. Find her average power. Take G is equal to 9.8 meter per second. So as you can guess that this 9.8 and this 9.8 will definitely cancel. That is why they have given you this particular value. Now what is the question? So you have a well, okay, and some lady is drawing some water which is 8 meter deep. Okay, so 8 meter deep, she is drawing some water. Now how much work she is doing, and time is given 9.8 seconds. So if you can calculate the work that she is doing and divide it by the time, then we can calculate the power, right? Average power basically. So what is the work done? Work done is basically force into displacement. Now what is the force? Force is basically here, the force is mg. Okay, she is doing the work against mg, so she is pulling up the water, so she is doing the work against the gravitational force, right? So that means mg is the force, displacement is 8 meter. So what is the work done? So force is basically mg, m is given by 10 kilograms, g is given by 9.8. so here F is equals to mg, so 9.8, and s is given by 8 meter. Okay, so this is the work done. Now what is the power? Power is work done divided by time, that is 10 into 9.8 into 8 into divided by 9.8. so 9.8 9.8 cancels, so 80 watt. So very careful, you have to be careful with the units. Okay, in case you don't do it for the steps, I have to write the unit for the last part. Okay, this is very, very simple numerical question, and if you see this kind of similar questions is coming in your PU1 final exam, don't skip them. They are actually easy. You can solve it if you know how to solve them. The thing is very basic equations, very basic formulas you can use. Nothing rocket science, nothing difficult. Okay, now question number 30. Relatively your final 5 marks question will definitely be difficult. Question number 33, what is meant by equilibrium of a rigid body? Write the conditions of equilibrium of a rigid body. Let's see. A rigid body is said to be in equilibrium when it remains at rest or moves with a constant velocity under the influence of external forces. This means that there is no net force or torque acting on it. So, equilibrium of a body means it is moving, it is either at static condition or it is moving with a constant speed in a particular direction. So, conditions for equilibrium, basically there are two types of equilibrium. Translational equilibrium, the sum of all the external forces acting on the body must be 0. Rotational equilibrium, the sum of all the external torques acting about any point must be 0. Now, question number 34, state the 3 Kepler's laws of planetary motion. Let us see Kepler's first law, law of orbits. Every planet moves in an elliptical orbit around the sun, while with the sun is one of the foci of the ellipse. Okay. So, we know this is I am not going to explain this, these are very well known statements. Kepler's second law, a line segment joining a planet and the sun sweeps out equal areas in the equal intervals of time. This is called laws of areas. Okay. And you do not need to explain, you do not need to draw diagrams or explain anything unless they specifically say that state and explain Kepler's second law or state and explains Kepler's third law. These two can also come in your exam, maybe as a 2-mark question. Okay. So, there you have to draw the diagram, explain that equal areas in equal interval of time, whatever is given in your textbook. So, Kepler's third law, law of periods, the square of the orbital period t of a planet is directly proportional to the cube of the semi-major axis r of the orbit. So, basically it says that t square is proportional to r cube. Okay. This is the third law of Kepler. You have to remember them, you have to write them, practice them, and explanation also. When you are practicing, you have to practice the explanation for this and explanation for this as well. Okay. They are also important. Now, question number 35, what is meant by streamline flow and turbulent flow? Write the equation of continuity. So, first let us see streamline flow. Streamline flow is the fluid particles move in a parallel layers without mixing. Each particle follows a smooth, well defined path. So, basically when liquids are flowing without mixing, each layer are following particular direction, then this is well defined path, that is called streamline flow. And turbulent flow is fluids move in a irregular and chaotic manner. It is characterized by swirls, vortices and mixing of fluid layers. So, basically it is like this. So, they are mixing the layers, okay, and it can have swirls, vortex, okay, anything is possible. So, for example, just if you visit a seashore, you will see that the waves are coming. So, they are kind of turbulent flow. Okay. Now, we have to write the equation of continuity as well, which is very easy. A1 V1 equals to A2 V2. This is the equation of continuity. A1 is the area of the area, and V1 is the speed at the first position of the fluid. Suppose the fluid is flowing through to pipe like this. This is A1, this is V1, this is A2, this is V2. Okay, so this is called the equation of continuity. Okay, you can simply draw this diagram and write this, that will be fine. You don't need to explain too much about it. Show that the volume coefficient alpha V is 1 by T for ideal gas, where T is the absolute temperatures of the ideal gas. Now, what is the volume coefficient alpha V? So, volume coefficient alpha V is basically defined by 1 by V dV by dt at constant pressure. Okay, this is the definition of alpha V, that is volume coefficient. Okay, so pressure is constant because we cannot change volume and pressure simultaneously. So, either volume coefficient or pressure coefficient you have to calculate. So, when you are calculating volume coefficient, pressure will be constant. Now, for an ideal gas, what equation does an ideal gas obey? Ideal gas obeys the equation PV equals to nRT, right? This is the ideal gas equation. Now, what we have to do? We have to differentiate this equation with respect to temperature T on both sides. Okay. So, if you are not familiar with differentiation, okay, then you can skip this question completely and move to the next question. Okay, now on the right hand side we have only temperature, so it will be only giving you Nr. It will be become 1. Now as I said, in this case pressure is constant. So pressure constant means pressure can be considered to be a constant. It will come out of the differentiation, only dV by dt will be here. So dV by dt is equal to Nr. Okay. So now what we have to do, we have to find this P is making some disturbances here, right. So we have to remove this P. How to do that? From our mother equation. This is the mother equation. So P is basically Nr T divided by V. Okay. Now we have to use this P in this equation. Okay. So what we can do, we can say that Nr T by V into dV by dt, dV by dt, right, at constant pressure is equals to Nr, right. Now what we have to do, we can cancel this Nr, and it does not become 0, it becomes 1. I have seen students, they cut both sides and make it 0. Now we can take this temperature T to the other side. So and on the left hand side it will be left with 1 by V dV by dt at constant pressure is basically 1 by T. Now what is this? So this is from the definition of temperature volume coefficient. This is the volume coefficient, right. So we can say that alpha V is basically equals to 1 by temperature. Okay. Now next question. Now we are into the 5-mark category. Okay. So illustrate the conservation of mechanical energy in case of body dropped from a height capital H. So we have a body of mass m, say, okay, it is dropped from a height h and it reaching to the ground. So the height is given by capital H. Very easy derivation. If you see this derivation, don't miss out on that. Now initially at position 1, this is position say 1. Okay, we have to do it for 3 positions. What are the 3 positions? First is definitely the starting position 1, then somewhere in between the position 2 where say height is say h, and that the third position is just before touching the ground. If we can show that energy is equal in all these 3 places, then definitely we can find the conservation of mechanical energy, right. So first let us calculate the energy for position 1. So position 1, entire energy is potential energy, kinetic energy is 0, right. So it will be mg into h. So for position 1, you have to mention for position 1, and also you have to describe the diagram. Suppose an object is started from a height h, it is falling at some intermediate position, it is reached at a height small h, okay, and just before the hitting the ground, its position is denoted by 3. That is you have to describe. Now next is position number 2. Position number 2, suppose the speed in this case is say v2, because position is 2 marked by 2, so I am mentioning this v2, and v1 was basically 0. Okay. In this case the height will be 0. So potential energy will be 0 in the third case. Second case is the most critical, where neither potential energy is 0 nor the kinetic energy is 0. So what is the meaning of that? So first of all, total energy is basically given by potential energy plus kinetic energy. Potential energy is easy to figure out. Because the height is small h, so it will be definitely mg small h plus Ek. Now Ek you need to calculate. That is the main thing that you have to do in entire derivation. That second stage ka Ek you have to calculate. How to do that? Okay. So first of all, the object starts from rest at some height. Okay. After falling some time, it reached a height small h. That means how much distance it has fallen? It has fallen a distance is capital H minus small h, right. This much distance it has fallen. when it started here. Now you cannot use the conservation of energy itself here, because you are trying to prove that. So what you can do is that you have to use other formula, that is motion in a straight line, right. The object is moving under the acceleration due to gravity g, right. The object was moving under the acceleration gravity g, and initially it started with 0 velocity. Its displacement is given by h minus small h. So what is the velocity, right. So velocity formula is v square equals to u square plus 2g h minus h. 2as, let me write so that you understand the what formula I am using. So 2as, this is the formula, right. V square is equal to u square plus 2as. Now in this case v2 square, we are trying to find v2, u is 0 plus 2 into g, right, gravitational acceleration, and s is capital H minus small h. So this is the formula for v square. Now what is the kinetic energy? Kinetic energy formula is simple, that is half m v square, right. So let's put that value here, half m into 2g h minus h. So 2 cancels, so you get mg h minus h. Okay. So the only step that you have to do is to calculate this. Okay. The same logic you can apply for the third position also, and same thing, you will get the same answer. Okay. So what you will get here, so kinetic energy you have calculated is this much. So what is the total energy? So total energy is mg h plus mg capital H minus small h, or you can break that minus, it will become plus mg capital H minus mg small h. So they will cancel each other. So what is left? Only thing that will be left is mg capital H. So this is the energy with which it started. At the position 2, it has the same total energy. So total energy of the system remains constant, right. So only thing, as I said, is you have to calculate is to calculate that intermediate kinetic energy, which might feel some trick. You might feel it is tricky, not actually. Okay. So basically after calculating everything, we see that Ek at this stage is basically given by, let me summarize it, this second point, Ek is basically calculated as mg capital H minus h. So total energy turns out to be mg capital H. Okay. Now we have to do the same for the third position. Okay. In the third position again we will start from the beginning. We will not take this intermediate point as our starting point. That will make the things complicated. Why? Because at the starting velocity is 0, right. So we are trying to find the final velocity v3. Okay. Same equation. What is the equation? v3 square equals to u square is 0 plus 2g, and in this case if you are starting from here, it is reaching to the end. That means what is the displacement? Displacement is h, capital H. So this is capital H. So from here you can say v3 square is basically 2g h. Now what is the kinetic energy in this case? So kinetic energy in this case is given by half m v3 square, that is half m into 2g h. So that is basically mg h. Now potential energy at this point is 0, height is 0. So potential energy is 0. So E total energy is basically Ek plus Ep, that is equals to mg h. So as you see, the starting position and ending position are relatively easier. Only the intermediate point that you have to remember, and also that if you remember the intermediate point, the same logic you can apply for the third position as well to calculate the kinetic energy. Okay. So kinetic energy calculation, you have to use the linear motion equations, not the conservation of energy. So once you have derived this, now you can use conservation of energy for any other principle. So I have seen students, they say that due to the conservation of energy, I can write mgh is equal to half mv square like that. So that don't do that. Okay, that you cannot do it here. Okay, then you will get 0 marks. So they have asked you to prove the conservation of energy, and if you don't do that, you do something else, then it will be a mistake. Now next question, define torque and angular momentum, derive the relationship between torque and angular momentum. The torque is the rotational equivalent of force. It is the moment of force about a point on the axis which causes the object to rotate. Mathematically, torque is given by r cross f. Okay, angular momentum is the rotational equivalent of linear momentum. It is a measure of rotational motion of an object about a given axis. Mathematically, L is equal to r cross p. Now what they have said, they told you to find the relationship between torque and angular momentum. Again we will use differential method. Okay, if you are not comfortable with differential method, you can use some other method, that is also fine as long as it is technically correct. So what you have to remember, that torque is basically like force and angular momentum is like angular momentum obviously. So the relation that we are expecting is to basically torque should be equals to dl by dt. Okay, this is the expected relation that we are hoping to find. Now how to do that? So we will not start with differentiation of L. We will start with the expression for torque first. So torque is basically given by r cross f. Okay, you can use scalar, you can use vector, that does not matter. So now what is f? F is basically rate of change of momentum. So rate of change of momentum means dp by dt. Now in case torque is acting on a system, the distance, suppose the distance for a particular moment is constant. Okay, so distance constant means you can say that you can write this as d dt of r cross p. Okay, assuming that at that point of instant r is definitely constant, r is not changing with time, there is no time component involved with r. So you can say this is the formula. So you can say this is what is r cross p? R cross p is nothing but angular momentum, so dl by dt. So torque is basically given by dl by dt. Okay, so similar to that, when differentiation, if there is a constant you can take that out. Similarly, if this is a constant outside, you can take that inside as well. That is the beauty of differentiation. If you do this using differential method, it is very short and simple and crisp. That is why I prefer this derivation over any other derivation. Let us move on to the next part. Derive an expression for the escape speed from the surface of the earth. So we have object kept on the surface of the earth, and we want to make it free from the gravitational pull of the earth. So how can we do that? So first of all, you have to see that what is the energy of this object when it is located at the surface of the earth. So you might feel that what is the energy of this object? So energy of this object is basically the potential energy of this object. That is, you can say that potential energy is minus gmm by r. Okay, gmm by r is the formula for potential energy. Now you can rewrite this as minus gm by r square into m into r. So we have multiplied and divided with capital R. Now why we have done that? Because we know that this is a constant, and this constant is nothing but acceleration due to gravity. So you can write this as mgr. This is the potential energy. Okay, this is the potential energy on the surface of the earth. Okay, now if we give it sufficient kinetic energy, okay, say kinetic energy Ek, so that the total energy of the object becomes 0, then it is basically free from the gravitational pull of the earth, right? If I want to make anything free from gravitational pull of the earth, then what we have to consider is that its total energy becomes 0. When it is on the surface of the earth, it is bound to the earth because its total energy is negative. That means it cannot leave. So it has a debt to pay. Debt means the money that you borrow from your friends. So it has to debt to pay. but once that date is moved by supplying kinetic energy, now it can go anywhere. So its date is now 0, right. So now what you have to do, what is kinetic energy? Kinetic energy say is basically, what is Ek? Ek is half m v escape square, right, formula same. So we have to put that value minus mgr. You can, by the way, do this side calculation while doing this equation as well. I like to keep my calculations clear, that is why I have done this in the first stage. Okay, so Ek is half m v e square equals to 0. So after escaping, the total energy must be equals to 0. So total energy is given by this equals to 0. Now you do the simplification, half m v e square equals to mgr, cancels. So v e square is equal to square root of 2gr. You can put the values, it comes out around I think 11 kilometer per hour, 11 kilometer per second, I think. Okay, so that is approximate value, but sorry, one more mistake I have made here. This will be, we have put the square root, right. So square root we have put, that means it will be square root of 2gr, that is the escape speed. This is the derivation that you are supposed to solve. Next question. Question number 40, state and explain 0th law of thermodynamics. Write the 3 differences between isothermal and adiabatic processes. Let us see. Statement, if two systems are each in thermal equilibrium with the third system, then they are in thermal equilibrium with each other. Explanation, suppose we have 3 bodies A, B and C. If A is in the thermal equilibrium with C and B is also in thermal equilibrium with C, then A and B must also be in the thermal equilibrium with each other, right. So basically it says that if A and B, 2 objects, they are in thermal equilibrium, A and B, 2 objects, they are in the thermal equilibrium individually with the third object, then these 2 must be also in thermal equilibrium. What is the meaning of thermal equilibrium? That means they are not exchanging any heat. Heat exchange is basically 0. Heat exchange is 0. Also it gives rise to the concept of temperature. There was also very popular question that state 0th law of thermodynamics and hence explain how the concept of temperature comes from it. Okay. In future another video we will do, there I will explain that question also, but that is a 3-mark question. Now question number 40, part B. So this is the part B answer. Okay. Write the 3 differences between isothermal and adiabatic processes. First of all, obviously the definition. Okay. A process in which the temperature remains constant is called isothermal. Isothermal means obviously temperature constant. Adiabatic means process in which no heat is exchanged with the surroundings, that is Q is equal to 0. Heat exchange, heat is exchanged with the surroundings to maintain the constant temperature. No heat is exchanged, all energy changes occur due to the work done. Okay. Now equation is PV equals to constant, and in case of adiabatic process PV to the power gamma equals to constant. You can add any other point that you think okay that may be relevant. Okay, that is also fine. Now question number 41, with schematic diagram showing the components of restoring force, derive an expression for the time period of an oscillating simple pendulum. So we have a simple pendulum. Okay, and we are trying to find the what we are trying to find, time period. Okay, this is slightly complicated derivation, and if you don't want to fall in this derivation you can skip this part, but since it is given in the book and it is given in your sample paper, we are going to solve it. Suppose this is a position where the pendulum bob is located. Now at this position what are all the forces acting on it? Okay, so first of all there is a force mg of the bob. Okay, then that mg has 2 components, one is along this direction one is along this direction, mg cos theta, this is mg, and another one is in this direction, perpendicular direction, that is mg sin theta. Okay. So, if this is theta, that means you can say this angle will also be theta. So, what are all the forces acting on this? There is a force mg downward. Okay. I have some colors, so let me use the colors, and we have one force along this direction, one force along this direction. Okay. Now, if you see this and these lines are parallel, okay, they both are in this orientation, and this is the similar angle. So, this angle will definitely be theta. If this angle is theta, means this component is mg cos theta and this component is mg sin theta. Okay. Now, this mg cos theta component is balanced by the tension of the string. Okay. And this component is basically providing the required force, restoring force required for the motion, right. Now, what is the torque acting on this system? The torque acting on this system will be definitely given by this length L, okay, times the force. This is the torque, right. So, mg sin theta into L, this is the formula for torque. Now, what is torque in terms of rotational dynamics? Rotational dynamics, torque is I omega. So, it will be mg sin theta into L. Okay. Now, what is omega then? Omega will be equals to mg sin theta into L divided by I. Okay. Now, you have to understand that here the simple harmonic motion is only possible if the value of theta is very, very small. So, a simple pendulum oscillates in the simple harmonic motion only if the value of theta is very small. So, for small theta, sin theta is nearly equals to theta when theta is expressed in radians, right. So, for small theta, sin theta is equals to theta. So, omega is basically equals to mg. There is a negative sign, by the way. Why negative sign? Because theta is pointing in this direction, but torque is acting in the opposite direction. So, there will be a negative sign. Okay. You have to be careful. In case you forget, you just need to add it later on. So, mg theta into L divided by I, or it will be minus mg L by, sorry, one more mistake I made. It is not I omega, it is I alpha, angular acceleration, angular acceleration. Okay. So, as I said, this is slightly tricky, so be careful. Now, this is mgl by I into theta. Now, we know that if this was a linear motion, okay, linear acceleration is minus omega square into x, right. For linear motion, it is linear acceleration is equal to minus omega square into x. Similarly, for angular motion, it will be minus omega square into theta, right. X is the displacement, a is acceleration, here alpha is acceleration, theta is the angular displacement. So, by comparing with this equation, we can say that omega square is basically equals to mgl by I, right. So, this is the formula, or omega is basically equals to square root of mgl by I. Now, this is a simple case where pendulum bob is rotating and we do not assume the mass of the string, it is a massless string. So, in that case, I can be written as ml square. Okay. So, we can say that omega is basically equals to mgl divided by ml square, that is equals to square root of g by L. Okay. This is the formula for omega. Now, what is time period? Time period is basically given by t is equal to 2 pi by omega, right. This is the formula for time period. So, just do that. So, it will be 2 pi into square root of G by L. It will be inverted because it was in division. So, it will be L by G. The famous equation. The formula might be you might remember, but what happens is that in the exam, student, if you forget any one of the steps, you will not be able to find the derivation. This is a tricky derivation, that is why I said if you practice it, okay, otherwise do not attempt such question, okay, that can be proven harmful for you. So, it is 2 pi by omega or T is equal to 2 pi square root of L by G, okay, this is the derivation, right. And if you have any questions, you can mention that in the comment section below. Now, let us move on to the 5 marks numerical questions. A ball is projected with a velocity of 50 meter per second in a direction making an angle 30 degree with the horizontal. Find the maximum height and the time of flight of the ball. For what angle of projection the range will be maximum. Now, even if you do not know the answer, the final answer is easy to know, that range is maximum for angle of projection 45 degrees. So, this is the 45 degrees, this is the first part that we will answer, okay. But in the exam you have to maintain the order. The first question is that we are projecting a projectile with the velocity 30 degrees, angle 30 degrees, okay. Speed is 50 meter per second, okay. Then we have to find the maximum height and time of flight. So, maximum height and time of flight. So, what is the formula for H? So, you have to remember the formula. If you remember the formula, it is very easy to know, okay. So, maximum height is basically u square sin square theta by 2g, right. So, this is the maximum height. Maximum height is u square is 50 square, sin square means sin 30, 50 whole square. I will not do the final calculation, that is up to you, okay, divided by 2 into 10, okay. You can take G is 10, okay. Final calculation, it is up to you, 2500 divided by 20 into 4. This calculation you have to do, that is the final height, maximum height of the or attained by the projectile, okay. Now, next is time of flight. Time of flight is again given by, so time of flight, this is the cos component, this is the sin component. Again, anything happened in the vertical direction always related to the vertical component, that is u sin theta, right. So, it is given by 2u sin theta divided by g, okay. This is the time of flight. So, let us see, 2 into 50 into half divided by 10. So, that is 5 seconds. 5 seconds is the answer. Now, question number 43. A man pushes a car of mass 2000 kg at rest along the horizontal road with a steady force of 300 Newton. The resistance of the road is 0.05 Newton per kg. Find the velocity of the car at the end of 20 seconds and distance travelled by the car. Very interesting. So, a man is pushing a car, okay. How many of you can draw the car? Let me know. So, it is a car, a man is pushing with a force of 300 Newton, sorry, okay, and the mass of the object is basically 2000 kg. So, the weight is basically 2000 kg into g, that is the weight, right. And it says that, so okay, one thing that we do not need to calculate the weight, okay, because the unit of friction is given by 0.05 Newton per kg. So, resistance is basically friction, okay. So, you have to calculate the frictional force, okay. Frictional force is given by 0.05 Newton per kg. So, what is the force of friction? Force of friction is basically given by 0.05 into 2000. Okay, so that will be equals to 20 into 5, that is 100 newtons. Okay, so 2 zeros you can cancel with these 2 zeros, and then 20 into 500. Try not to use calculator as much as possible if you want to attempt any competitive examination in future. So what is the net force? So the net force is basically equals to F minus Fs, that is 300 minus 100, that is 200 Newton. This is the net force. So what is the acceleration then? Father equals to ma, right? Father is 2000 Newton, 200 Newton, sorry. Ma is ma starts with 2000 kg. So what is A? So A is basically 200 divided by 2000, that is 1 by 10 or 0.1 meter per second square. This is the acceleration. So this is the acceleration, means now you have to calculate the velocity after 20 seconds. So velocity after 20 seconds means v is equal to 80, or in this case yes, 80. Use the simple formula. 80A we have calculated 0.1 and t is 20 seconds, so that will be 2 meter per second is the velocity. Now how much distance it has travelled? S equals to ut plus half at square, ut plus half at square, u is 0, so it becomes 0 plus half, a is 0.1, and t square is 20 into 20, right. So it will become 2 will cancel, it will become 10 into 0.1 is 1, so it will be 20 meters. So even after it is pushing very hard, it only moves by a distance of 20 meters. So you have to be careful. First you have to calculate the net force, first you have to calculate the frictional force, then you have to calculate the net force, and from the net force you have to calculate the acceleration, then simple equation of motion. Okay. Next question, the base of a copper boiler is 2 centimeter thick. Now this is a difficult question. I will give you the hint, but I will not solve it. In case you are interested, mention in the comment below. I will post it as a separate link to you. Okay. Because most students don't solve these questions from this chapter. Okay, most of the 2 important questions that you have to solve will come from motion in a plane and Newton's laws of motion. Okay, so that 2 chapters, if you are new to PU1 final exam, you have not done any numericals, so these 2 chapters are your go-to chapters. Okay, the base of a copper boiler is 2 centimeter thick and has an area of 0.1 meter square. Steady difference in the temperature between its faces is 5 K. Calculate the mass of the water evaporates in the 1 hour given the thermal conductivity of copper is 385 and latent heat of steam is joule per kg. So first of all, what is happening? You are heating the base 2 centimeter thick. Okay, so you have to use the formula for heat transfer. How much heat is transferred from here to here? The difference is given by 5 K. Okay, so Q is equal to Ka T by D. Okay, so this is the formula. So you have to delta T basically, obviously T1 minus T2 or delta T. Okay, so this is the formula. Conductivity is given here. Conductivity of copper K is given here. Okay, then area is also given. Okay, then area is given in meter square, whereas the thickness is given in centimeter, so you have to convert it into centimeter. Calculate Q. That Q, okay, is for every second. Okay, now you are doing it for 1 hour, that means total heat will be 3600. 3600 is the 1 hour per second. So this is for this much heat is transferred per second. Okay, the total heat transferred is basically 3600 into Q, and then that should be equals to ml. Okay, so how much mass is your question is how much ice is melting, right? Given the mass of the water that evaporates. So, mass of the water that evaporates, that is mass, and latent heat of evaporation L is given. So, use just this equation and you calculate that how much mass is getting evaporated. Okay, I will not waste too much time in this. Last question, a string 1 meter long under the tension of 440 Newton. If the fundamental frequency is 100 Hertz, find the mass per unit length of the string. What is the mass of the string? So, tension is given by 440 Newton. Again, I will leave this with the formulas only. I will not going to solve it. And if the fundamental frequency is 100 Hertz. Okay, find the mass per unit length. Now, what is the formula for fundamental frequency? 1 by 2L square root of tension divided by mu. Here mu is the mass per unit length. Right, this is the formula for frequency. If you use this formula, okay, you can calculate frequency is already given 100 Hertz. Okay, tension is given, you need to calculate, put the value, length is given 1 meter. Using that value you can calculate whatever is the mu is. Now, the total mass will be mu into L. Okay, L is 1 meter and mu you can calculate. From there you can calculate the total mass. This is the formulas. Okay, if you are interested, you can solve these questions on your own and let me know in the comment below whatever your answer is. Okay, and this is me completing this model paper 1, and if you have any doubts, any questions, don't forget to mention that in the comment below. And in future, very soon we will be doing more lectures for physics, chemistry, maths, biology for your PU1, so that you can score at least 80% in your PU1 exam, even if you are starting right now. I hope you have subscribed to our channel if you have not done so. I will be back. Till then, bye.